Isotopes. So we've been talking about protons and electrons. And we said the protons in an atom are always the same. Every atom of carbon has 6 protons. An atom will have 6 electrons, but then it can form an ion. It can gain some electrons, it can lose electrons. What about the neutrons? Well, the neutrons, the number of neutrons can vary from one atom of an element to another. And these are called isotopes. So an isotopes are atoms that have the same number of protons, they're members of the same element, but they have different numbers of neutrons. So they're just a little different, okay? Iso is a prefix meaning the same. So they're the same, and yet they're not exactly the same. We can't predict from the periodic table what the isotopes are or how many there are. Most elements have at least 2 isotopes. And the relative abundance of the different isotopes is fairly constant over the entire planet. So if you look at carbon that you isolate from a piece of wood here in the valley and you compare it to carbon that you isolated from something in Egypt, I don't know, papyrus or something. The relative percentages of the different isotopes would be very close to the same. And those are called natural abundances. It's the percent of those atoms that are of this isotope and then another isotope and another isotope. So let's look at an illustration of this. So neon. We mentioned neon before. Neon is actually the gas that is in neon signs. So they're called neon signs. And neon has 3 different isotopes that occur in nature. They're called neon 20, neon 21, and neon 22. Neon 20 has 10 protons and 10 neutrons. Neon 21 also has 10 protons. All of them have 10 protons because that's what says this is neon, 10 protons. But this one has 11 neutrons. Neon 22 has 10 protons and 12 neutrons. So slight variation in the number of neutrons. And here's an illustration. If you looked at a sample of neon atoms, 90%, 90.48% would be, what is that color? This one? Neon 20. So neon 20 is the most common one. Little over 90% of all neon is that one. 9.25% is neon 22, and only 0.27% is neon 21. So this one's unusual. But you look at multiple samples of neon from different places, the relative abundance is going to be the same. Well, we have different ways of symbolizing the isotopes, because if we just use the symbol neon, it doesn't indicate which isotope we're talking about. Most of the time, we don't care about which isotope we're talking about, but we need to learn how we would indicate which one it is if we would happen to care. So this is what's called a nuclear symbol, where the capital X here would be replaced with the chemical symbol of that particular element. And then we use a superscript and a subscript on the left of it to indicate the mass number and the atomic number. We've talked about the atomic number. That is the number of protons. The mass number is the number of protons plus neutrons. There were 3 main subatomic particles: protons, neutrons, and electrons. And what did we learn about the mass of the electron? It's so small that we really don't need to think about it, right? It's like, if you're weighing yourself on a bathroom scale and you've got a pocket full of, a small handful of coins. Those would be like the mass of the electrons compared to your body being the mass of the protons and the neutrons. Does it really matter in terms of the mass on the scale whether you have the change in your pocket or not? Doesn't really matter. And so those coins do have mass, but it's so small compared to everything else that it doesn't really matter. So the mass number is the number of massive particles. It's the protons plus the neutrons. And that has the symbol A, and atomic number has the symbol Z. I really would like someone to explain to me why they chose those letters. Personally, I think A should stand for atomic number. Wouldn't that be reasonable? And then if you're going to use Z, give it to mass number. Anyway, so I will not hound you about A and Z. But what you do need to know is that the number on top is the mass number, and the number on bottom is the atomic number. And it actually works out kind of conveniently this way, because if you stack these up and subtract, that gives you the number of neutrons. Because the top number is protons plus neutrons, the bottom number is protons. And so if you subtract the protons, you get the number of neutrons. And sometimes we need to know how many neutrons. So for this guy over here, how many neutrons does neon 22 have? 12. We just stack it up. That also helps me to remember, which one do I put on top in the symbol? Well, you put the bigger one on top. The mass number goes on top, the atomic number goes on the bottom. So these are the symbols for the 3 isotopes of neon. Any questions? So the mass number A, the sum of protons plus the neutrons. And yeah, we just went over that already. A second type of notation is where we take the element symbol or its name and a dash and just the mass number. And so we could call it neon Ne20 or neon 20. Here we're leaving off the atomic number. What if we need to know the atomic number? Where would we find it? Periodic table. A chemist is rarely without a periodic table. I have one on my phone, right? Because you just never know when you're going to need to look up something in the periodic table. That's how chemists think anyway. So we don't really have to specify the atomic number because that's available on a periodic table. What is not available on the periodic table is the mass number for the particular isotopes. There's no way to predict that from the periodic table. So let's do an example here. It's asking for the atomic number, the mass number, and symbols for the chlorine isotope that has 18 neutrons. Well, let's write some stuff down. So they're saying there's 18 neutrons. I'm just calling them N. N is a symbol for neutron. 18 neutrons. This is chlorine. How many protons does a chlorine atom have? 17 from the periodic table. So it's got 17 protons. So they want the atomic number. That is Z. What's the atomic number for chlorine? It's the number of protons. So 17 is the atomic number. The mass number equals the number of neutrons plus the number of protons. So what does that equal? 35. And then symbols, plural. So if we write the nuclear symbol with the superscript and the subscript, what goes at the top over here? 35. And what goes at the bottom? 17. So that's one way to specify this particular isotope. Another is the symbol chlorine dash 35. It's the mass number that we're going to stick there, because we can find this on the periodic table, or we can write the element's name, chlorine 35. There's an isotope that you've probably heard of before, carbon-14, right? Carbon-14 dating. They use it to find the age of really old stuff. The 14 is the mass number of that isotope. Any questions about this? Here we're given a symbol and asked how many protons and neutrons are in the potassium isotope indicated here. So how many protons? 19. And how many neutrons? 20. So the number of neutrons comes by subtracting those. Okay? So there's information hiding in these little symbols.